Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, we will be solving a problem on equilibrium of coplanar concurrent forces. So let us look at the problem. Here, determine the amount and direction of the smallest force P. Here, the force P is acting and this must be minimum such that required to start the wheel. So a wheel is climbing over an inclined plane of 30 degrees with horizontal, right? And the block, of course, what is the reaction at the block? So you are pulling this to override a hurdle. You have a hurdle in the form of a zero 0.5 meters height, and the wheel diameter is the wheel radius is 2 meters, and the force is acting. So he is asking what is this value of P such that P should be P minimum in order to climb over the hurdle. So that is the problem. So now let us understand very clearly in this particular problem. So in order to become P minimum, so here the reaction, here the moment the reaction is acting through the point of contact, this is what is your reaction R, right? And this angle, I am erecting a perpendicular to the inclined plane. So this angle is given, that is 30 degrees. This angle is 30. And of course, this angle you can calculate the theta value, because this height is 2, total is 2 minus 0.5, this is 1.5, and this is radius, that is 2 meters. Radius is 2 meters. So this is reaction R. Let me represent here. Okay. So here you can, now from this right triangle, so this becomes adjacent side, and you can write down cos theta is equals to, it is adjacent is 1.5 divided by opposite hypotenuse is 2 meters, and this gives you theta value 41.4 degrees. So this angle is 41.4 and this angle is given 30 degrees. So total angle with vertical becomes it is 71.4 degrees. This is 30 and it is 41.4, together is 71.4. That means the reaction R is at an angle with the vertical 71.4. Now the moment it climbs over the hurdle, so it loses contact on the inclined plane. So there is no reaction at the contact point on the inclined plane. So you have only reaction at the hurdle. And if you see the number of forces, R is the reaction and P is the force acting, and weight is given 2000 newtons, and you have a problem with 3 forces, right? And let us represent these 3 forces. Force here, the weight is acting downwards, that is 2000 newtons, right? And this angle, if you extend this, the angle between this and vertical, this becomes, between the vertical and the reaction, maybe reaction is like this. So this becomes, 71.4 degrees, the angle between these two. So this is the reaction R. This is the reaction R. And the moment you calculate this angle, so it is 180 minus 71.4. So this angle is 108.4 degrees, the angle between these two forces. And as I said, it is a P. To become minimum, it must be perpendicular to the reaction R, so that P becomes a P minimum. So the angle between the force P and R must be 90 degrees in order to become, your P becomes a P minimum. So that is the condition for that. Now you can calculate the angle between the vertical, this angle, it is, of course, it's 90 and this is 71.4, and of course this is 90. So 90 plus 71.4 is 161.4 degrees. Now you got all the angles. This is 90, The angle between the reaction and P minimum is 90. The angle between the R and the weight is 108.4, and the angle between P minimum and the weight W is 161.4. So you have represented all the forces on a coordinate axis, and you have three forces, all are diverging forces. You can apply comfortably Lami's theorem. So according to Lami's theorem, as you know that each force is proportional to the sine of angle between the other two forces. You want to calculate P minimum. So let us write down P minimum divided by sine of angle between the other two forces, that is 108.4 degrees, which is equals to, or also you want to calculate R divided by the angle between the other two forces, that is this angle, that is sine, it is 161.4, is equals to the weight, that is 2000 newtons. 2000 divided by the angle is 90, it is sine 90. So from this you can calculate the P minimum as well as R values. So P minimum is equals to, it is 2000 divided by sine 90 into sine 108.4. So this gives you, it is the answer is 1896 newtons. This is one answer. And your R becomes, R is equals to, it is 2000 divided by sine 90 into, that is sine 161.4 degrees, and this gives you, it is 638 newtons. So these two are the answers, that is the P minimum as well as the reaction offered by the hurdle upon the wheel. Thank you very much for watching this video.